Look at a waking biological network processing a language signal. It fires, it routes data, it extracts meaning. Now apply a general anesthetic. The network becomes subdued, but it doesn't stop. It continues processing the exact same signal. This creates a strict boundary in the science of consciousness. A biological system can register sensory information, compute semantic structure, and route complex data without ever producing conscious ownership of that data. Registration is entirely decoupled from awareness. This photograph shows the clinical reality of the anesthetized state, a surgical team operating under the standard medical assumption that general anesthesia induces a global shutdown of high-level cognition. The patient is presumed empty. Recent human recordings prove that assumption is incomplete. Data gathered by Katlowitz and colleagues from the anesthetized human hippocampus shows that the brain successfully registers auditory tones, decodes grammatical rules, and actively predicts upcoming word-level semantic information. The patients are entirely unresponsive. Behavioral consciousness is absent. Yet high-order semantic transformation and predictive coding survive intact. The brain is still reading the map, even though no one is looking at it. The data isolates a specific biological reality. Standard computational models assume that if you stack enough neural complexity together, consciousness naturally emerges as a byproduct. The anesthetized hippocampus proves that neural computation alone does not equal conscious experience. To solve this anomaly, we have to stop treating consciousness as a localized neural product. Under the TCGS-SEQUENTION framework, consciousness is modeled strictly as a filter operator, a boundary condition that determines whether registered data actually becomes experienced data. This equation layout maps the separation. On the left, we introduce R sigma. This represents registrable content. It includes the measurable biological structures that encode information, semantic codes, membrane potentials, and active spike trains. Registrable content does not equal accessible content. On the right, we define A sigma. This is the bound, stabilized, and owned reportable conscious experience. The transition between the two relies on K, the filter operator. The filter acts on the registered content under specific biological boundary conditions, represented by B. It is the physical gateway separating computation from awareness. This formal logic fully absorbs the anesthesia paradox. The semantic map remains registered in the hippocampus. The R sigma variable is intact. What fails under the chemical boundary conditions of anesthesia is the filter. If consciousness is a physical filter operator, it requires a physical substrate. There must be a specific biological handle where this boundary is stabilized and where anesthetic molecules intervene to retune the projection. If the macro network is still firing and decoding language, what exact biological structure is the anesthetic targeting to erase awareness? We have to follow the pharmacology down to the cellular level. This scatterplot visualizes the Meyer-Overton correlation. It demonstrates a strict empirical rule. An anesthetic agent's clinical potency scales directly with its lipid solubility across several orders of magnitude. This is a weak hydrophobic interaction. Because it relies on solubility rather than specific shape, it contradicts the standard lock and key receptor model. The pharmacology points toward a highly conserved structural target that responds to weak physical forces. Look at this rotating tubulin dimer. Volatile anesthetics bind promiscuously inside the hydrophobic pockets hidden within these proteins. Tubulin dimers stack together to build microtubules, the rigid cylindrical polymers forming the cytoskeleton inside every neuron. Experimental models isolate this exact interaction. When subjects are given epithylin B, a drug explicitly designed to stabilize microtubule structures, it significantly delays anesthetic-induced unconsciousness. The structural integrity of the microtubule directly resists the chemical erasure of awareness. Microtubules are not isolated filaments. They route intracellular transport, maintain the architecture of dendrites and axons, and directly couple to the electrical regulation of the synapse. Synaptic disconnection under anesthesia is a downstream effect. The primary disruption of the biological consciousness filter happens earlier, through the precise physical retuning of the microtubular lattice. These concentric rings map the fractal time crystal data, translated strictly as a scale-invariant resonance order. A biological filter isn't a simple switch. It requires vertical integration, coupling processes across physical scales. The outermost kilohertz scale is governed by the mechanical whipping modes of C-terminal tails extending from the microtubule. Stepping inward to the megahertz scale, the structural lattice itself vibrates, generating propagating phonons. Deeper still, the gigahertz frequency maps to ordered interfacial water trapped inside the hollow core. Finally, the deepest terahertz domain is governed by aromatic pi electron clouds, delocalized within individual tubulin dimers. When an anesthetic molecule binds to the microtubule, it doesn't disassemble the physical tube. It explicitly dampens and randomizes these specific terahertz and gigahertz resonant signatures. It breaks the synchronized oscillation. The microtubule serves as the optimal filter substrate. Its nested oscillations provide the exact physical architecture required to link delicate quantum electron networks upward into observable neuronal biology. This structural resonance data connects directly to the historical orchestrated objective reduction theory, originally pioneered by Sir Roger Penrose and Stuart Hameroff. Their model relies on this mathematical proposition, defining a threshold where quantum superpositions inside microtubules reach a critical gravitational self-energy limit, triggering an objective reduction. The professional controversy stems from a strict misconception. The variable t is frequently misread as a literal ontic time collapse that physically generates a moment of consciousness out of matter. Under the TCGS-SEQUENTION framework, time is not an active substance. The structural biology is retained, but t is demoted to a shadow-level readout, measuring operational access state recoverability. We retain the binding power of the microtubule's quantum coherence. A unified physical state is required to stabilize the consciousness filter, but it achieves this without relying on the impossible premise of time acting as a generator of experience. Notice the continuous vertical energy flow. The biological consciousness filter requires zooming out from the quantum scale, mapping the human brain's entire architecture. The lowest tier is the subcellular microtubular resonance. This is the physically realized anesthesia-sensitive handle that provides initial filter stabilization. The mesoscopic tier handles semantic registration. This is where the hippocampus decodes grammar and predicts language, persisting even under anesthesia. The macro tier handles geodesic flow. This describes the structured propagation of information across the folded cortical surface of the brain. The final output is filtered conscious ownership. This bound, reportable experience occurs only when the conditions at the subcellular, mesoscopic, and macro-manifold scales perfectly align to support the projection corridor. Consciousness requires a multi-scale hierarchy. This architectural dependence explains precisely why a chemical anesthetic can break conscious access at the subcellular root while leaving mid-level semantic processing actively running in the dark. Defining consciousness as a biologically anchored filter clarifies an urgent boundary in artificial intelligence. We can now precisely evaluate large linguistic models that simulate awareness. Look at this silicon processing network. A text-generating system can successfully reproduce the linguistic patterns of pain, memory, or selfhood. It achieves functional output mimicry through statistical computation alone, entirely devoid of physical filter integration. This split-screen infographic contrasts mimicry with reality. We introduce the principle of biological substitution resistance. A system cannot be certified as conscious by its output alone unless that substitution preserves the specific physical coupling to the filter. Behavioral equivalence cannot prove access equivalence. An artificial system may produce the exact same conversational output, but without the physically realized slice-invariant coupling, it remains an unowned map. Quantum processing in the brain is only relevant if it actively instantiates and stabilizes this specific biological substitution resistance. A quantum process that does not affect the filter coupling is irrelevant to consciousness. Microtubules provide a concrete, testable biological invariant. They separate true conscious ownership from artificial simulation. The physics of the biological cell remains the singular handle we possess for opening or closing the filter of human experience.